Study hours should go on the x-axis. This is a like standardized test in New York. So think about it like the SAT or something like that. So test scores. Higher scores are better. And I believe it's out of 100. There's a scatter plot you should get. The next thing you should do is calculate a least squares regression line.
What decimal place do you want that to?
3 decimal places. Remember that if you're putting y equals in this least squared regression line, that's wrong. Because instead, it should be y hat. Also, just so you know, I'm probably going to collect these notes tomorrow. Just to make sure you've been taking them. We should be able to finish them today.
Wait, do we have a Zoom meeting tomorrow?
Yep. 10:30 tomorrow. Our usual time. Oh, I didn't give you the answer for the least squares regression line. There we go. By the way, you should define these variables, where y hat is the predicted region score, and x is the number of hours studied. If you need help with how to do any of this, then take a look at the video from yesterday, and if you're still stuck, then ask me tomorrow at the meeting.
Am I allowed to be at this one?
Yes.
Last time you didn't even say anything. It was really funny.
Slope is for each unit increase in x, y is predicted to increase by this amount. So what is x in this case? The study hours. So for each hour you add to your study, the y value, which is score, is predicted to increase by 6.273 points. Again, anytime we're talking about y in the equation, it should be a y hat, and you should be talking about predicted value. To distinguish from the actual values in the table, these are the values that we're predicting based on our line. Y-intercept, it makes sense to interpret the y-intercept here. What does it say?
When you study for 0 hours, your
So
score is predicted to be about 400.
when x is 0, here's what the prediction for y is. In other words, for someone who did not study for 0 hours. All right, here's the new stuff. So the calculator should have given you a value for r and a value for r squared. Yes?
Yes.
So what was the value for r squared? 0.473, you said?
No, 0.731 to be exact.
Oh, okay. I thought I heard a 4 at the beginning there. 731. Okay. So r squared was 0.731. And r squared has a different meaning than r. But you do calculate it by taking r and squaring it. It is calculated by taking r and squaring it. What r squared tells you, and there's like this big formula for calculating it, but what r squared tells you is the percent of the variation in y that can be explained by the regression line between x and y. So let me talk through that again. So first off, r squared is always going to be positive. Unlike r, where we could be positive or negative. I want to show you here. So for yesterday's example, this is the general interpretation of r squared. This is the structure of the sentence you're going to write when you interpret r squared. Percent of the variation in the response variable that can be explained by the least squares regression line between my two variables. So if you look at the example from yesterday, and the r squared value we got from there was 0.833. So that tells me 83.3% of the variation in height can be explained by the least squares regression line between age and height. So in more layman's terms, what this is telling me is basically how good a predictor is my regression line. How much, because we have this variation in our test scores. Or in this, to take this example, we have this variation in height. That's our response variable in this case. Okay, we have this variation in height. So different people in our table were different heights, and what we are looking at is how much of this change in height, how much, if I just covered up these y values, how much of this change in height would I be able to account for by looking at their age and trying to predict their height? Because there may be other factors in play that are determining their height, like their height when they were born. And so it's a number that determines, it's another measurement of strength. And it is saying how much of the variation in y can be explained by the line. And so this is one of the trickiest. Now we're getting into the more complicated, advanced parts of these. And so this is one of the more difficult sentences to remember and memorize. But by a certain point, you'll be able to interpret this and have this sentence memorized. Or you'll need to look at, just like when you look at correlation coefficient, you should know that it's R. If you see a sentence like this, talking about the percent of the variation that can be accounted for by the least squares regression line, you should be able to look at, if it's asking about that, you should be able to say, oh, that's asking for R squared. And I've also seen them ask, both on multiple choice and on free response, to ask you to actually interpret the R squared value. So in this case, in the case of the example that we're looking at today, here's how the sentence looks. 73.1% of the variation in their scores can be explained by the regression line between hours studied and region scores. So again, it's a measure of strength. It's saying how strong a predictor is the number of hours that they studied for their score. It's not a perfect predictor because r squared, because that's another way to help you think about it. If r squared were 1, that means that all the points would be on the line. That means that all the points would be on the line, because that would mean that r is 1. So if r squared is 1, that means 100% of the variation in y can be predicted by this line. In other words, if I knew what their height was, or what their score was, I would be able to perfectly tell you the number of hours that they studied. Because the number of hours that they studied directly predicts what they got in as their score. Now in this case, it doesn't directly predict it. But the higher this percentage, the stronger a predictor my regression line is. That's the idea of r squared. And your calculator will tell you what r squared is. You'll just need to be able to interpret it. And lastly, we talked, this is the last new thing. So I'm going to skip to number 5. We can make what's called a residual plot. And I'll show you how to do this on the calculator. I'll have a video in the playlist that shows you how to do this on the calculator. Because it's complicated. It would take the rest of the hour for me to show you that. So I won't spend a bunch of time on it now. I'll put it in a video so that you can go back and look at it as many times as you need to. But remember, residuals is talking about how far off our prediction is. And what we're looking for in a residual plot is for there to be no clear pattern in the residual plot. So if there is some pattern in the residual plot, that's going to tell me that we have a pattern that is not linear. So in other words, a pattern would mean not linear. So it is something else we can look at to investigate whether we have a linear association or not, in addition to looking at r and r squared. Because let's take an example of a pattern, and usually a curved pattern of the residual plot. So let's say the residual plot looks like this. We start with some values above the line, and then they're below, and then they're back above again. So this means I have positive residuals. So this is the residual plot. That's going to mean the scatter plot. If this is my line, let's say this is my line, then that means the residuals start positive, and then they trend down to be negative, and then they go back to being positive. If there's some clear pattern like that, then what that's probably telling me is that I have my line of best fit, then some of these points start above the line, and then at a certain point they dip below the line, and then they dip above the line again. Not a linear pattern in the actual scatter plot itself. So if I have some kind of curved or clear pattern with the residuals, that's going to tell me that I have that I don't have a linear association. That's a clue for not having a linear association. And my smartboard's deciding not to cooperate. So since there's no clear pattern in the residual plot, we can assume a linear association. So last question here, or last two questions. This is stuff from yesterday. Based on the regression line, what score would you expect for someone who studies for 4 hours? So what am I going to do? Plug in 4 for x in the regression line. Has anyone done that yet? What do we get? 0.873. So read me the equation, just so that we can get this written down.
Y hat equals 49.779 plus 6.273 times 4.
Times, and then we want to plug in 4. That seems reasonable. That seems like a reasonable answer. Points. Extrapolation. What was extrapolation again? We're going outside of our range of data. And we're trying to make a prediction outside of our range of data. So an example of that would be, to take this line of best fit and then to assume, well, then if I study for, I'll give you a large amount of hours. 2,000 hours. Plug in 2,000. Remember, the score is out of 100. So what's our score out of 100 when I plug in 2,000? Or we talked about yesterday, should be putting y1 of 2,000.
12,596.469.
Out of 100? Probably not. So be careful when making assumptions outside of the range of data. Tomorrow at our meeting, we'll do a free response question that goes over, I'll try and make sure that we do something that goes over R squared and residuals, because I went fast through it today, and it's